binomial expression. If I give you 2 cube, you know what it means. 2 cube means 2 multiplied by 2 3 times. Number of times is indicated by the index. This is the index. This would be the base. So 2 would be multiplied by 3 times. If I give you x cube, how can we expand that? Same. X, it would be multiplied thrice with same x quantity. Same thing in binomial expression as well. If I give you y minus 1, it's cube. So what would be the expansion? It would be y minus 1 times y minus 1 times y minus 1. This is the simplest way of expansion. Y minus 1. So 2 cube, we can multiply that to find the answer as 8. X cube, it is x cube. The expansion would be x into x into x. Y minus 1 cube, the expansion is y minus 1 times y minus 1 times y minus 1. So we will see how to expand this. So we cannot multiply three expressions directly now. First, let's multiply both of these expressions. I'll multiply both of them. Y minus y 1 times y minus 1. So I can express this one as y minus 1 whole square times y minus 1. Somehow we want to multiply this. So that's why we are taking this y minus 1 times y minus 1. I can express it as y minus 1 whole square times y minus 1. Okay, this is the one I did. Thereafter, we know y minus 1 whole square means we can write that one as y square minus 2y plus 1. We know that binomial expression. So y minus 1 whole square, this was expressed as y square minus 2y plus 1. Likewise, we have another y minus 1 expression as well. Here what we need to do? First, I will multiply everything by this y minus 1. Everything should be multiplied with this y minus 1. So first of all, I will multiply y square with y minus 1. Then negative 2y, it should be multiplied with y minus 1. Then positive 1, it would be multiplied with y minus 1 as well. Don't confuse with this, it's easy. This one should be multiplied. Everything should be multiplied with each other. So that's why it's little complex to multiply directly. So that's why we are writing them in a order. Y square, the whole function should be multiplied with this whole function. So we cannot multiply that one directly. So you should write them as steps. First, I will split this one to three particles. So each should be multiplied with the secondary function. Y square multiplied with y minus 1. Thereafter, negative 2y should be multiplied with y minus 1. Then finally, 1 should be multiplied with y minus 1 as well. Next, let's write the expansion. That's all. Y square times y, it would be y cube. Y square times y, it is y cube, minus y square times 1, it is y square. This is just multiplication and expansion. Y square times y, this is y cube. Y square times negative 1, it's negative y square. Next one, negative 2 times y, it would be negative 2y square. Then negative 2 times negative 1y, it would be positive 2y. In the final bracket, 1 times y, it is 1y. 1y or y. I'll write it as 1y. Then finally, 1 times positive 1 times negative 1, it is negative 1. Okay, from the beginning again, what we did here? Y minus 1 cube. So that was expressed as individual triple multiplication. So to do the multiplication, I just denoted this one as y minus 1 whole square. We know the expansion of y minus 1 whole square as y square minus 2y plus 1. It should be multiplied with another y minus 1. Thereafter, each were expanded with their respective values, we got something like this. So final answer would be, I'll write the remainder over here. Y cube, only we have one cubic function, y cube. Here also y square, negative y square. Here also negative 2y square. Both together negative 3y square. You should do the get the sum of likely terms. Sum of likely terms. Both are y square having some coefficients. So negative y square and negative 2y square, that will become negative 3y square. Thereafter positive 2y and positive 1y, that will become positive 3y. Finally, the constant, it could be negative 1. It could be negative 1. This is the expansion of the cubic function. Y minus 1 whole cube, it would be y cube minus 3y square plus 3y minus 1. We have some tricks to find this directly. Okay, rather than doing like this, we can find them directly. First, we will try some questions with this method. So somehow you should know about this basic method, no? How this came from. Thereafter, I'll explain by using the simplest method. So while we are expanding k plus 4 cube, first I can express k plus 4 times, k plus 4 times, another k plus 4. To make the multiplication easier, we can consider k plus 4 times k plus 4 as a square one, because same values are multiplied twice. No? I can consider both of them as k plus 4 whole square times k plus 4. So k plus 4 whole square, what would it be? It would be k square plus 2 times 4 times 8, 8k plus 4 square, it is 16. It should be multiplied with another third party k plus 4 expression. That means this total function, it will be multiplied with this total function. We cannot achieve the multiplication directly. That's why we are using the part by part multiplication. So each k square should be multiplied with both of them. 8k should be multiplied with both of them. Thereafter 16 also would be multiplied with both of them. I will split this. I will split the multiplication properly. First, this k square, it should be multiplied with both of them. K plus 4. This is not addition or subtraction. These are multiplication. So that's why we are keeping like this. This value should be multiplied with this expression. Again, this value also should be multiplied with, I will use different colors to indicate. K star should be multiplied with this expression. Thereafter, this positive 8k also, it should be multiplied with k plus 4 expression. Thereafter, finally, the numerical, which is positive 16. This one also should be multiplied with k plus 4 expression. This is the tricky part. If you achieve this correctly, furthermore, just expansion and sum. Get the sum of operations. That is really easy. So you should understand how this one came from. That's why I use different colors to indicate what is happening over here. K star should be multiplied with the secondary expression 8k. This one also should be multiplied with the secondary expression. Thereafter, this 16, it should be multiplied with the secondary expression. Now let's expand this expression. K square multiplied with k, it is k cube. Then k square multiplied with 4, 4k square. 8k multiplied with k, it is positive 8k square. 8k multiplied with 4, it is positive 32k. Then 16 multiplied with k, here this expansion, it is 16k. Then finally 16 multiplied with this 4, it is 64. 64. Now let's do the final answer. I'll write that over here. K cube. Only cubic function exists in this expression is k cube. So that remains same. We will get the sum of likely terms. Both are having k square quantities. No? So positive 4k square and positive 8k square. That will become positive 12k square. And thereafter, k. That one also. Those are likely terms as well. 32k and 16k both are having k quantities, so we can do the operation between them as well. 32k plus 16k, it would be 48k. And finally, this number, this would be the expansion of the given cubic function.